How's it going, class? This is Mr. Miles, and coming at you with another podcast, and this is going to be on Chapter 2, Lesson 3, and if you're following along the book, it's going to be on page 56. Okay, so today we're going to be talking about the protists. Now, if you guys recall, the protists fit into a different category, because the last two lessons they talked about bacteria and viruses. And remember, viruses aren't a living organism. Bacteria is going to be its own group, the prokaryotes. But when we get into protists, these are going to be the first of the eukaryotes that we're going to be meeting today. So, protists, eukaryotes. Remember, this is because they have a nucleus. So as we learn about the protists, we're going to be introduced to a few cute little critters. Now remember, protists, it fits under the kingdom. So remember, there's domain, and the next one down is kingdom. It fits under its own group called protists, which is right next to fungus, plants, and animals. And we'll be getting into fungus and plants shortly, and then eventually into animals. So let's get started with protists, shall we? Now, the first thing to understand about protists is that they can't be classified as animals, plants, or fungus. So the thing is, these are kind of like the oddballs. You know, that one friend that you have that you just have no idea what to do with them. And so they set them up in their own group, and you can get different types. You can either get autotrophs with these guys, or you can get heterotrophs. And again, remember, auto means self, hetero means different, so it's either a self-feeder doing photosynthesis, or a heterotroph, meaning it's going to be eating other protists. And we're going to get into different types of protists, and really what we're going to find is that protists actually match very closely to animals, to plants, and to fungus, but because they're not quite there, we give them their own group. So the first one we're going to look at is we're going to look at the animal-like one. So these are the ones that are very close to being animals, but they're just not quite there. And so these ones are going to be called our protozoans, and this is a really fun name. I've always liked this one, and it just means animal-like. So I'll drop that, put this in there. So it's animal-like. So these are all going to be unicellular, and these are going to be our friends. Now let's look at a few different types of animal-like protists that we could be running into. You're going to get different types classified mostly on how they live and how they move. So the ones that we're going to look at, because these are really important for understanding structures that exist on them, is this guy right here, is our friend. And if I were to draw this, you probably might be able to recognize this thing as an amoeba. And, you know, we've seen amoebas, you know, kind of reminds us of that one old piece of crap horror movie with the blob. Well, what an amoeba does is it moves forward by actually pushing out a part of it, gripping onto it, and then pulling the rest of the body forward. And so it uses it as like a foot. But the whole thing is it's not really a foot because it's just an extension of the blob. So we call it something called a pseudopod. And again, pseudo means false, and pod is supposed to represent foot. So it's just saying that this represents a false foot. So it acts as a foot, even though it's not really, and amoebas will use this. Another important thing on the amoebas is this thing right here. They're going to have these little circles inside of them. These are called contractile vacuoles. What these do is these actually will take in excess water and help eject it out of the amoeba. Because the thing is, these amoebas are always going to be living in watery environments. So again, if you want to know the scientific writing for water, it's 2 hydrogen, 1 oxygen atom to make H2O, water. And they live in this environment. The contractile vacuoles make sure that they don't bloat up too much and pop from all the water that they're around. Now, the next one we're going to get is protozoans with flagella. Now, we remember our friend, the flagellum before, but here's a new one. This kind of looks like something off of, if you've ever seen any of the Matrix movies, but no, of course not. You're all too young when you get older. And this one, they're going to use the little whip-like tails, and before we had seen ones that, you know, just kind of have one. So here's our friend, the euglena, where he's going to have just one flagellum, but you can actually get ones with many flagellum, and they use these as whip-like tails. We can also get other ones that kind of resemble these flagellum, but they're going to be a lot smaller. and they're going to be like little hair-like structures, and they're actually supposed to be connected onto it, but I didn't do the greatest job of drawing it. These things are called cilia. These are little hair-like structures, and if it wants to move, it actually just uses these hair-like structures. The best way to think of it, just if you've ever seen like a millipede, one of those nasty little bugs with all those little legs move, it'll use these as almost like little oars through the liquid, and it can move itself through there, just like little oars, and so it can navigate its way through the water. Now, moving away from the protozoans, remember those are the animal-like, we're going to go into the plant-like. And I love these guys. These guys are called euglena. Now, the reason why I like the euglena is because, you know, they're green, and they have a specialized little red eye spot. And I don't want you to confuse it with, you know, an eye that we have where we can, you know, see images, see space and stuff like that. This eye spot's mostly just used to detect light. It can tell where light is. And that's extremely important for this thing because, again, there's a reason it's plant-like. It seems that evolution has favored this little bugger right here, and he actually has the ability to do photosynthesis with these little chloroplasts that he's gotten in throughout his evolutionary history. So these guys are going to be the most important, probably I would say, of the plant-like ones. You're going to get other ones, but you know, when I say important, I mean what I think, you know, is my favorite. We can get other ones called dinoflagellates, and if you can, I would look it up in the book. It's on page 61. If you don't have your book with you, search for what these things look like. And again, these are all little, very, very tiny little creatures, little unicellular creatures, but dinoflagellates are really awesome. We're also going to get ones called diatoms. And diatoms are also really cool. They create really cool shapes. They make hard casings to protect themselves. And also these are the ones where, if you've ever heard your parents talk about diatomaceous earth, they'll actually use these because they are very sharp, but because they're so small, we don't really notice it. We see it as a powder, but sometimes people will lay these things down, these crushed up diatoms, to actually kill insects and to keep them from actually getting inside the house. They'll do that instead of using chemicals. We're also going to get two different types of algae. You're going to see the red and the brown. And these algae are going to be the multicellular protists. So these are obviously going to be a lot bigger. If you look up what red algae looks like, you can go ahead and guess it's going to be red in color. Brown algae, again, brown in color. And these things can get very large. And again, they don't really fit perfectly into plants, so all of these find their way into protists because they are all eukaryotes and they do have that nucleus holding in their DNA or RNA. Now, when we look at the fungus, like, we're going to run into a few different ones. We're going to run into slime molds. And this is definitely something you should Google. Slime molds can get very gross. It literally looks like just like a nasty booger you got from your cold, like a monster booger. These ones are going to be heterotroph. They use spores to reproduce. So again, we'll put the H for heterotroph. They're going to use spores, and we'll find out from fungus that spores are a very common thing they use, so that's why we group them with that. And if you remember from bacteria, spores are this protective casing, so I guess this little circle is perfect. It's a protective casing that allows, you know, what would normally kill a fungus or bacteria to last a lot longer in harsh conditions. We're also going to find, water molds and downy mildew. And again, you guessed it, it's just mold that can grow on water, and those ones aren't exactly the funnest to be looking up on Google, but hey man, if that's your thing, you go right ahead and you do that. But again, yeah, that's protists. To recap, just in case anybody wanted another recap, Remember these ones. Oh, there's my favorite little drawing. These guys are going to be eukaryotes. They were kind of kicked out of the animal, plant, and fungus because they don't fit perfectly, but they have some characteristics that are close. They can be autotrophs or heterotrophs. The first ones you're going to get are the animal-like, which are the protozoans. These are little unicellular guys that can either move by pseudopods, flagellum, or cilia. Then you have the plant-like. You get a whole bunch of different ones. You get diatoms, cyanophlogellates, red algae, brown algae, or my favorite, the euglena. These guys are all going to be in there because they do photosynthesis. And then the last one you're going to get is the fungus-like. Remember, these ones aren't going to do photosynthesis, and what gets them so close to being like funguses is the fact that they're going to be using spores and how they grow out. So, all right, that's the podcast on protists. I hope you had a fun time, and until next time, I will talk to you later.